All right, so for problem number 1, what we have to do is, it says a solid sphere that is 3 kilograms, so let's label that, has a mass, and we'll just call it the mass of the sphere, is equal to 3.0 kilograms. It has a radius. It goes from the center of this bad boy to here. Now this is it says that the radius r is equal to, in fact, I know for a fact that one person got one question wrong. See how that says 33 centimeters? What do I need to change that to? Yeah, I need to change it to meters. So that's 0.33. Right. Oh, I hate when my little pen tablet thing does this. I want to write fast, and the computer needs time to think, I guess. All right, and then the last bit of information is that they tell us that the angular velocity, omega, equals 3.7. Now, since omega is positive, remember that means that it has to turn counterclockwise, right? Truthfully, I'm being a little particular about this because I want you guys to know, because there are positive and negative rotations. So because they gave us an angular speed or angular velocity, that we need to know that it is, because it's positive, it's counterclockwise. And that's radians per second. And it's already in radians, so we're good there. What's the total energy of the ball? Well, if you flip through your notes, somewhere in there they have energy, or how can we calculate energy? Does anybody remember how to calculate energy? Well, you probably don't remember this, but if we take and we go that the energy, let's think about kinetic energy. So remember, this kinetic energy is equal to, oh, this is frustrating, 1/2 times the mass of the object times the velocity squared. Do you guys remember that? Okay. Well, I can, you may not remember this or not, but this is kind of difficult. If I go through my equations, okay, we can actually convert this to rotational energy, right? So for rotational energy, it's actually 1/2 omega squared, okay? Now, where that comes from is you have to remember that your linear velocity is equal to omega times r squared, right? And I guess technically we could just plug that in here. And since we have the mass, right? But what we really want is the moment of inertia. So now to get the moment of inertia, so there's two ways to do this problem. If I want to get the moment of inertia, which we briefly talked about, that is, and that was so long ago, you probably don't remember writing that down. It's 2/5 times the mass times the radius squared. And that derivation is kind of difficult. Whoops, I wrote the wrong symbol in there. So what I'm trying to figure out, there's two things. The ball is rotating, that's rotational energy. That's this stuff here. But also it is moving in a linear path. That's this stuff here. To get the total energy, we have to add the two. Okay. So, all right, let's calculate this stuff over here. So the angular velocity is 3. Oh, geez, this is really going to be frustrating to me. So the angular velocity is 3.7 times the distance, or the radius, which is 0.33. That is going to equal 1.22. And that's meters per second, because that's a linear velocity. Now, the moment of inertia for the solid ball is 2/5. So we're going to say 2/5 times the mass of the ball, which is 3, times the radius. I wonder why it does that. After I've been doing a bunch of these, it starts to go wonky. Times the radius, which is 0.3. And then we square that. And that's 0.131. Okay? And that's kilogram meters. Squared. So we have, now we have all the information we need to finish this problem. So then the total energy is equal to 1/2. This is very frustrating. Times the mass, which is 3, times the linear velocity, which is 1.2, squared, plus 1/2 times the moment of inertia for a rolling object, which is 0.131, I'm sorry, times the angular velocity, which is 3.7, squared. And that is equal, if you do that in a calculator, and I'm afraid to do it in the calculator because I feel like my computer is going to crash any second, 3.13 joules. Now that's a tough one because it combines almost basically everything that we've done up to this point, right? Any questions on that one?